Hey guys, hoping all is well with everyone. So in this video we are going to be looking at our question of the day, and this one's going to be in the realm of 8th grade level middle school math. So the question asks us to represent the repeating decimal 0.45 repeating as a fraction of two whole numbers. Now before we even jump into any of the step-by-step approach, I want to do a little bit of vocabulary recall. So remember that repeating decimals are defined as rational numbers, and the reason for that is that they can be expressed as a ratio of two whole numbers in which the ratio is to a over b. The only constraint to that is that b cannot be equal to 0. So again, repeating decimals are going to be rational numbers, and they can be represented as a fraction. The other number that can be represented as a fraction when it comes to decimals are decimals that terminate. They have a stopping point. In comparison to that, on the opposite side of things, irrational numbers do not terminate or end at any point. They go on infinitesimally. So an example of that is pi. Pi just kind of goes on forever. If you ever have the opportunity, you can look up the results of pi reciting competitions where students around the world just try to list off as many digits as they can, and it's absolutely incredible. But again, it doesn't have a stopping point. Other common irrational numbers are numbers that are typically like the square roots of prime numbers. They just go on forever and ever without any kind of order to them or repetition. So now that we have that, we're going to kind of go into our step-by-step approach, and our approach is going to be that our goal is to eliminate the decimal part of the repeating decimal itself. And it sounds counterintuitive, but there will be a definite method to the madness here. But what I'm going to do is use algebra to define a variable and create a relationship with itself and another like term in representing of the decimal components that we're trying to eliminate here. So step one is going to be, let the defined variable x be equal to the repeating decimal. Okay. So what that means for us in our case is that x is going to be equal to 0.45 repeating. Okay. Now this is where things get a little tricky, because I'm going to be using the same variable again, but what I'm going to do is I'm going to let 100x equal 100 times that amount. So if x is equal to 0.45 repeating, then 100x is going to be equal to 44.45 repeating. So again, it's a factor of 100 times greater, but you're still going to be having that continuous repeating decimal component. But in just a moment, we're going to be able to get rid of it. So again, we're going to go ahead and let that. Step 3, well, I'll say step 2. So step 2 is going to be let the expression, or let the equation 100x minus x be equal to 45.45 repeating minus 0.45 repeating. Okay, and remember, these still are repeating decimals. But essentially, what that does is you're going to allow yourself to eliminate the repeating component of this decimal. So step 3 is to solve the equation by first simplifying the left and right sides by combining like terms. Okay, so what that means for here is we have 100x. And remember, if it's good for housekeeping purposes and it makes you more comfortable, remember that if a variable doesn't have a coefficient on it, you can represent it as a coefficient of 1. Because of that multiplicative identity of 1, anything times 1 is itself. So x times 1 is just x. But if it helps you with the combination of like terms, which it may very well here, you're more than welcome to do that. And then what's going to happen here is the 45.45 repeating minus the 0.45 repeating is just going to become 45. So now that step was very pivotal to this whole process because we got rid of the repeating decimal component of our question here. And now what we have here is just a situation where you can now combine the like terms on the left, which is going to be 99x is equal to 45. Now this now becomes a single step equation, and I'm going to go ahead and complete it over here. So step number 4, determine the value of x by dividing both sides of the equation by 99. Okay, so here we have 99x equals 45, and then we're going to divide both sides by 99. So on the left side of that equation, you're going to get that 99 divided by 99 is again just 1, but because again of that multiplicative identity of 1 times x is just x. So now x is fully isolated. Now what you're going to do here is you have the fraction, which was our ultimate goal here, as 45 over 99. But what we have to do is we have to reduce it to its simplest form. So, what we have to do there is we have to find the common ratio or the greatest common factor between the two. So we can go ahead and to determine our greatest common factor, we can make those factor trees. Some of you may know it as the ladder method. Both work completely fine. So 45 and 99 are our numbers in question. So I'm going to say that because they're both odd numbers, I can't use the prime number 2 to start my prime factorization, so I'll start with 3. So 3 times 15 is 45, and then I can break it up a little further. 3 times 5 is 15. So now I have 45 broken down into its prime factors. And then 99 will be 3 times 33. And then 33 is a product of two prime numbers being 3 and 11. So now what we do is we look at the greatest common factor by determining all of the common prime factors they have. So here their common prime factors are going to be 2 pairs of 3's. So remember here, everything is multiplied. So the GCF is going to be 3 times 3, or 9. So I can take that, I'll go ahead and say GCF equals 9. So, and then I can divide top and bottom by 9. And I'm going to get that the numerator will be simplified to 5, and the denominator will be simplified to 11. So my final answer is going to be that x is equal to 5 over 11. And remember that one of your steps to the stages of approaching math problems is to check for validity and soundness, making sure that your answer makes logical sense. So if we have the decimal 0.45 repeating, that is almost about 1/2 or 50%, which can be represented as the decimal 0.5, and we're slightly under that because if it was 0.5, it'd be 5.5 over 11. But again, we can't. That would have nullified our goals in this whole approach to this problem in the first place. So we have slightly under half, which makes logical sense that our repeating decimal is 0.45. Okay? But I hope this helps you guys out with all the steps here. Again, if you have any requests for any type of problems, please don't hesitate to reach out and message me. But I hope you guys are all doing well in your preparations and your final exams. Please take good care of yourselves, and we're looking forward to seeing you next time in our question of the day. Thank you so much. Bye.